Simplifying an expression by applying the properties of exponents is a crucial algebra skill, not only because we have to do it from time to time in algebra, but more so because it really is going to test your ability to break apart an algebraic expression and systematically apply a set of rules to simplify it. In this example, we'll look at how to simplify this expression, which involves powers of x and powers of y, and all of the arithmetic operations of multiplication, division, and exponentiation. Our ultimate goal is going to be to simplify this expression so that x and y appear only in a single factor with a single exponent, and we would like for that exponent to be a positive number. So because we're simplifying an expression, as we always will when we simplify expressions, we will follow the order of operations and use the order of operations to set a priority for which parts of this expression we'd like to look at first and which parts we can leave until later. For each of the parts that we look at, our job is going to be to transform the arithmetic that's happening to the powers of x and y into arithmetic that happens instead to the exponents, the numbers themselves that are in the exponents of those powers. If we were to follow the order of operations then, the first thing that we should look at are any quantities which are in parentheses. Any quantities which are multiplied or divided inside a set of parentheses, and then that quantity raised to a power, may be simplified using the distributive property of exponents over multiplication. In other words, in this example, the quantity x to the fifth times y to the minus 2 being raised to the third power, because of the multiplication inside the parentheses and the exponent on the outside of the parentheses, that exponent may be distributed and applied to each of the factors inside the parentheses. So we can turn this expression into quantity x to the fifth raised to the third power times quantity y to the minus 2 raised to the third power. This intermediate step is often skipped by many students simplifying an expression like this one, but I'm going to encourage you to leave it in to reinforce why this works and also to give us a tie-in to the next rule that we're going to look at. Now that all of our expressions with parentheses no longer have multiplication or division inside of the parentheses, we're ready to move on in PEMDAS from the P to the E and look for any expressions that involve raising an exponential expression, raising a power of x or a power of y, to another power. Here we see that there are two examples, both of which were created in our previous step. We're raising x to the fifth to the power 3, and we're also raising y to the minus 2 to the power 3. According to the exponent rules, when a power is raised to a power, we can transform that arithmetic into arithmetic in the exponents by choosing to multiply the exponents together. So in our example, x to the fifth raised to the power 3 becomes x to the power 5 times 3, or 15, and y to the power minus 2 raised to the 3 becomes y to the power negative 2 times 3, which is y to the minus 6. Having simplified all of the powers of powers in our expression, we're ready to move on from the E in PEMDAS to the M, and look for any place in which two powers of the same base are being multiplied together. So in our expression, we're going to look for any instances where a power of x is multiplied by another power of x, and or when a power of y is multiplied by another power of y. When that happens, and we can see one instance of it happening here, x to the fourth times x to the 15th, we can transform that arithmetic, multiplication of powers, instead into addition of their exponents. So the total number of powers of x in our expression, when we multiply x to the fourth by x to the 15th, is x to the 4 plus 15, or x to the 19. Now there is no more multiplication of two powers having the same base inside of our expression. So we'll move on and look for any opportunities to divide. Specifically, look for where two powers of the same base are being divided one by another. In our example, there are two instances. We're dividing x to the power 19 by an x in the denominator, which has implicitly an exponent of 1 on it. We're also dividing y to the power minus 6 by y to the power 2 in the denominator. In each of those expressions, we can transform the division which is happening to the powers into instead subtraction applied to the exponents. So the total number of x's that we'll wind up with when we divide x to the 19 by x to the 1 will be x to the power 19 minus 1, or x to the 18. Likewise, when y to the minus 6 was divided by y to the 2, we can subtract those exponents and get y to the negative 6 minus 2, or y to the negative 8. Now we've achieved our first main goal in a simplification problem, which is to make it so that there is only one factor having each of our variable bases in it. We have only one power of x and only one power of y left in our expression. So the last thing to do is to transform this expression one last time in a way that takes any exponents which are negative numbers and trades them instead for exponents which are positive. In our example, the power of y to the minus 8, has a negative number in its exponent. We can turn any negative exponent positive by trading out multiplication of that power by division by that power. So to make a negative exponent positive, what we can do is move that factor, y to the minus 8, from the numerator of the fraction in which it resides to the denominator of the fraction in which it resides. Or, if the negative exponent were already in the denominator, we would do the opposite, move it from the denominator to the numerator. So when a power is moved from numerator to denominator or vice versa, the exponent will switch from negative to positive or vice versa. Here, because we haven't written this expression as a fraction, we can imagine that there is an invisible denominator of 1, and moving y to the minus 8 down into that denominator turns its exponent into positive 8 instead, and gives us our final expression, which we will use as our answer, x to the 18 over y to the 8. Gaining practice and skill with the application of exponent rules as in this example is maybe one of the best things that you can do for your mathematical brain in the second half of algebra. It helps you, first of all, get practice using the order of operations to break apart an expression and discover its component pieces. Where are their parentheses? What is being raised to an exponent? Where is their multiplication? Where is their division? And then, in each one of those cases, applying the rule of exponents which applies to that type of arithmetic, beginning by distributing any powers that apply to quantities in parentheses across multiplication and division on the inside of those parentheses, then taking any powers of powers and multiplying their exponents to simplify, then taking any products of powers and adding their exponents to simplify it into 1, and finally taking any quotients of powers and subtracting their exponents to simplify. If at the end of that process any of your exponents are negative numbers, this can be fixed by moving the relevant factor either from the numerator into the denominator or vice versa. Trading multiplication for division of the power trades a negative exponent for a positive, or vice versa.